All right, so we're going to talk about our third transformation, which is rotation. So I do want you to make a correction here for 180 degrees clockwise and counterclockwise. There's an error. It should be both x and y are the inverse. So when you do a rotation, you really have to know about the quadrants. So going in this direction is what we call clockwise. So that's here, clockwise. Going in the opposite direction, okay, is going to be counterclockwise. So counterclockwise. All right, so each quadrant is worth 90 degrees. So let's say we have we're starting in quadrant 1, okay? Here's quadrant 2, here's quadrant 3, and then here's quadrant 4. So say we're starting in quadrant 1. If you're going 90 degrees clockwise, this is where you end up. You end up in quadrant 4. If you go 180 degrees clockwise, you end up in 3. 270 degrees clockwise, you end up in 2. And then 360 degrees clockwise, you end up back where you started. All right, I'm going to kind of zoom in here so you can see it a little bit better. Now, if you're going counterclockwise, and it basically that stems from like a clock, right? When you look at a clock, which direction do the hands go? So if we're going to go counterclockwise, again, if we're starting in quadrant 1 counterclockwise, we usually do a negative. So one quadrant, which would be negative 90, two quadrants would be 180 degrees. 3 quadrants is 270 degrees, and then 360 would be back where you started. Now, take note, 180 degrees and 360 degrees, whether you're going clockwise or counterclockwise, makes no difference. Okay, so we're going to take a look at the first example here. So it says the triangle shown is our pre-image. Let's explore rotation. And we're going to do our rotation 90 degrees counterclockwise. All right, so when you take a look here, you notice you're going to go in this direction here, counterclockwise. So I can use the rules counterclockwise 90 degrees. So if we take a look up here, that's going to be this rule right here. So that means y becomes the inverse and x stays as is, but you notice that the x and the y end up switching places. So I can do that with one of the coordinates, for example, coordinate C. If I take a look at coordinate C, it is 2 and 4. So if I apply the rule being that x and y switch places and y becomes the inverse, for C prime, I would end up with, I have now negative 4 and then 2. So I can graph that 1, 2, 3, 4, and then 1, 2, and then my C prime would end up there. Okay, so you can apply the rule or you can use patty paper. So I'm going to go ahead and use the patty paper. Now I'm going to take my patty paper, place it over my triangle, and I'm going to label all of my points, all of the coordinates here. Now, whenever you're doing a rotation, it's always from the origin. So the way you do that if you have patty paper is you just kind of place your pencil or your pen right at the origin, and then you're going to turn it. Before we do that though, with rotation, it's so important that you label your X and Y axis and that you actually draw the axis on your actual patty paper. Because since you're doing a turn of a quadrant, you want to make sure that everything lines up perfectly. So I'm going to go in this direction here. So I'm going to make sure I trace my triangle. All right. So I'm going to go 90 degrees, which means I'm going to go one quadrant turn. So again, you can use your pencil, kind of line it up and then turn your paper, make sure your X and Y axis lines up. Or because you traced it, you can just go ahead and do one turn. All right, so we end up there. So we notice that with my patty paper and then with the rule, you notice your C prime ends up right where we said it was going to end up. All right, so then here is where my B is. So then I'm going to label B prime, and then A actually is the same place where it was. Okay, so there's my triangle. I'm going to go ahead and trace it. And let's talk about what we know about the two triangles. So how is the orientation of the triangle affected by each rotation? Well, when we take a look at the triangle, we notice that it was turned. So we're going to write that the triangle is turned. Now, how is the shape and the size of the triangle affected? Well, we just copied and pasted, right? So it started out as a triangle, it ended up as a triangle. The size did not get larger, did not get smaller, it stayed the same. So we're going to say that the shape and size are the same. So we know if the shape is the same, the size are the same, the size is the same, then the two triangles are congruent. So I can go ahead and write my congruent statement. Triangle ABC will be congruent to triangle A prime, B prime, C prime. All right, there we go. So now let's go ahead and take a look at another example. So we're going to take a look at example 1 down here. All right, rotate the triangle 90 degrees clockwise. So 90 degrees clockwise, when you take a look at your rules up at the top, 90 degrees clockwise, so that's here, right? So notice what happens to the coordinates. Well, x and y switch places, and then x becomes the inverse. Remember, x doesn't become negative, it becomes the inverse. If it was already negative, it will become positive. If it was positive, it will become negative. All right, so I'm going to go ahead and write the rule down here at the bottom. So I'm going to do y and negative x. Okay, so again, you can do it using coordinates. So for example, f is going to be 3 and 0. And then g coordinate is, let's see, 0 and then 1, 2, 3, negative 3. And then e is 0, 0. All right, so if I were to apply the rule, that would mean E prime is going to be, if we switch 0, 0, nothing happens, and 0 is neutral, so it doesn't hold a sign. Okay, so then E prime would be here, E prime. All right, and then if we were to do the same thing with F, remember X and Y switch places, so now I'm going to have 0 and 3, and then the X becomes the inverse. Okay, so I'm going to have 0 and negative 3, 1, 2, 3. There's your F prime. All right, and then your G prime, X and Y, remember they switch places, so I'm going to get negative 3 and then 0, and then the X becomes the inverse. Again, it's 0, so it has no sign. So negative 3 and 0. Actually, F 2, 3. All right, so G ends up in the same place. Okay, so we're going to go ahead and take a look. Now, what would it look like if I were to use the putty paper? So I'm going to go ahead and label my points. Okay, and again, when you're using your patty paper, you want to do your X and Y axis as well. Okay, so I'm going to turn it 90 degrees clockwise. So I'm going to go in this direction, 1 quadrant over. Okay, so there we go. And I think I got my points mixed up. I think I mixed up F and G. So I'm going to go ahead and fix that. So we notice that F ends up being here and then G ends up being over here. So I made a little mistake there. Not a problem. We can fix that. So here is my G prime. And then here is my F prime. Okay. So we can go ahead and we can trace our triangle. And then there we go. Your triangle is rotated 90 degrees clockwise. All right, so let's talk about what we know about my two triangles. So what do you know about the two triangles? Well, the size of the figures, are they the same? Yes, they are the same. That is a true statement. All right, and the angles of the two figures, they are the same. That's a true statement. The lengths of the corresponding sides are the same. Yes, that is true. If you count from E prime to G prime, we have 1, 2, 3 units. E prime to G prime, it's also 3 units. E to F, 3 units. E prime, F prime, 3 units, right? The two figures are then congruent. The two figures are not similar. That is false. All right, so again, you have your rules. You can definitely use your rules here, or you can use your putty paper. Okay, again, F was 0, negative 3, and then G prime is negative 3 and 0. All right, so now you can go ahead and pause the video and you try example number 2. You can use your putty paper or you can use the coordinate rule. All right, so let's take a look at example number 2 and let's see how you did. So the transformation, it says to rotate the figure 180 degrees clockwise. So if we take a look at our rule at the top, 180 degrees clockwise. Remember, this is the one I had you guys change because I had it wrong in the notes. 180 degrees clockwise and counterclockwise, remember they're the same. X and Y, they don't switch places, but the X becomes the inverse and the Y becomes the inverse. So again, you can do it using your coordinates. So for example, B is 1 and 2. So B prime is going to end up as, remember your rule is negative, or the inverse of X, the inverse of Y. So negative 1, negative 2. If I were to go ahead and graph that, negative 1, negative 2, my B prime would end up here. Okay, so you can do that for all the points, or again, you can always use your patty paper. I'm just going to do all of these with coordinates. So C is 4 and 2. So the inverse of this is going to be negative 4 and negative 2, right? There's your C prime. So 1, 2, 3, 4, 1, 2, C prime. Now A ends up being the same because A is 0, 0. Remember, the inverse of 0 is still 0. The inverse of 0 is still 0. So then D, we have 3 and 0. So the inverse of that would be negative 3 and 0. So 1, 2, 3, and 0. So there's my D prime. All right, so then there's your rotated figure. So it started out in quadrant 1. And then when we rotated it, it ended up in quadrant 3. All right, so again, if you wanted to see it with patty paper, you can take your paper, you can go ahead and trace your figure. You have your A, your B, your C, and then your D. Again, you want to make sure you're labeling your X and Y axis. And then you're going to rotate it from the origin. So that's 90 degrees. And then here's 180. You see where you end up? Perfectly there. All right, so let's see what we know about this figure. The size of the figure is the same. That is true. The angles of the figures are the same. Also true. The lengths of the corresponding sides, also true. The figures are congruent. Remember, it has to have those 4 pieces: the shape, the size, the angles, the lengths. If all those 4 things are true, they are congruent. They are not similar, right? Similar is not the word we want to use. It's not descriptive enough. We want to use the word congruent. All right, so if you have any questions, you want to rewatch any part of the video, go ahead and pause and replay. You want to make sure you're copying all these notes down inside of your notebook, and then you can go to Google Classroom and do some practice.